Solar Panel Final Project by Malorie, Dawson, and Alex. These are the learning targets that we strive to understand while doing this project. Identify sources of kinetic and potential energy within a system. Explain how energy can be converted from one form to another. Develop a model that demonstrates an energy conversion. Explain the law of conservation of energy. Build a prototype that maximizes energy efficiency. Utilize technology to improve energy conversion. This is our design challenge question that we created. How can we design a solar panel that will be handmade and absorb heat from the sun to be distributed into Mr. Uhde's greenhouse? This is all the information we gathered before building our prototype. It helped us understand what materials we should use and which would be more efficient than others. These are the list of materials we used and why. We had cans, plastic cover, aluminum foil, black spray paint, wood base, aquarium tubing, knife and pliers, and duct tape. The reason we used cans was to conduct the heat and then transfer it through a tube to another box, or for our final project, it'll go into Mr. Uhde's greenhouse. The plastic cover was to not let any heat out from our main box so that we can have the best results, and it was to cover the top of the can so nothing could get in. Aluminum foil was to conduct as much heat as possible, and we later took out the aluminum foil because in one of our experiments it showed that if we had aluminum foil or if we didn't, it'd be about the same temperature. The reason we had black spray paint was to spray paint the cans so that they would attract more heat, because black is known for attracting heat. The wood base is to create the structure to conduct the heat so that we can transfer the heat to another box. It was like our outside for the solar panel. Aquarium tubing, it was in the back of our solar panel, and that's for the heat to transfer into the greenhouse. We used a knife and pliers to cut holes in the cans so that the heat could travel through the cans and through the tubing. And we had duct tape to cover the cracks in the plastic covers. We chose this design because we thought it'd be the best option to transfer the heat from the main box to a bag to see if we could actually heat up an object. We thought that if we take 1/4 of our main blueprint and make that into a prototype, that'd be the best scale. 1/4 of the cans is also 1/4 of the wood, so that is how we got our dimensions. On the right is our blueprint that we created on graph paper. These are pictures of our prototype. The one on the top left has the tubing coming out, and that's where the heat transfers into the greenhouse. This was our first experiment, and our problem was, will the inside of the box create more heat with or without aluminum foil? We concluded that it doesn't matter if you use aluminum foil or not, the temperature inside the box was around the same. This is our second experiment, and our problem was, will the solar panel heat up over 5 hours and 30 minutes? We concluded that the temperature in the box can get high. Our highest point was 140 degrees Fahrenheit. This was our third experiment, and our problem was, if the door to the greenhouse is open, will all the heat be let out? We concluded that not all of the heat will be let out. When we did our experiment, only 6 degrees dropped from the temperature to when the door was opened for a minute. We now know that when Mr. Uhde goes into the greenhouse, the temperature will only drop a little bit. Some changes that we made were we put duct tape around the whole box because it was cardboard, and if it got wet it would soak, and the duct tape helps it so if it gets wet it'll just slide right off. Also, we took out the aluminum foil because it didn't matter whether or not we had it. This is our conclusion over the whole project. For this project, we had tested our prototype 3 times to see what the strengths and weaknesses of our prototype were. We first tested our first question, and that was, would putting aluminum foil in our solar panel increase the heat conduction inside our solar panel? To answer that, we set up our prototype outside for 10 minutes without, and then another 10 minutes with aluminum foil. We then found out that the temperature inside didn't change. We took the aluminum foil out of our prototype. Our second experiment, we tested the question of, will the solar panel be able to keep heat inside for a time of 5 hours and 30 minutes? We tested it, and we found out that yes, if we put it outside for that long, we can keep the temperature inside the box at a high temperature. It reached 140 degrees Fahrenheit. Our final experiment was to test the question, if the door of the greenhouse is left open, will it lose heat?